Welcome to a new edition of the Engineering Quick Tips.
Hello, Dave here again for part 2 of our fire monitor system design. If you're getting to this video and haven't seen part 1, stop it and go back to 1 for the setup. Alright, so let's get started. Here's an isometric view of our tanker for the our system setup. Monitor up front, sea chest in back, 800 feet in between. Alright, let's go to the setup or the basic strategy. We're going to use carbon steel pipe, schedule 80, wall thickness. Our suction pipe will be assumed 50 feet long with 10 elbows, 2 butterfly valves, pump elevation of 5 feet above the baseline, that's ABL. Water line at 10 feet ABL. The distribution pipe after the pump to the monitor will be 40, or actually 1,000 feet assumed. 40 standard elbows, 2 butterfly valves, 1 globe valve, 1 check valve, and the monitor elevation is going to be 5 foot above deck, so that places it 105 feet ABL. Okay, I'm going to set up the system in pipe flow. I already have pipe flow up. One of the first things you do when you open pipe flow to start a new system is you go up and hit system, and you want to set up fluid zone, which is the fluid that you're going to be pumping through a piping system. Then you will set up specifications, which deal with the type of pipe that you're going to be using, the pipe material and pipe thickness, and then you're also set up the units up here. And we are going to use the English units in our example. They're already set up in there in my pipe flow is English to start with. So what I've done here is I've already set up these 3 things, and I'm not going to go through that in this video. What I wanted to do was just kind of show you. I already set up the system just like we had spoke about in our setup and strategy. And this is what it looks like if back here is where our sea chest is, and we're going all the way up forward to our monitor. So our sea chest up and then to a pump in the machinery space, and you're going kind of outboard with the pipe and then up underneath the deck, and then all the way forward to the monitor, and then we're going to penetrate the deck to show where the monitor is going to be located. All right. I'm going to go through that just to show you how that gets input into pipe flow. So I'm just going to duplicate what I've done here so you kind of see how that's done. So first thing you do is you start with your pipe, or you can start with the sea chest, but I'm going to start with a pipe here. I'm going to draw just a little outline of our first piping system there, and I left clicked to start. I left clicked here, and I right clicked here to finish that little pipe. And that's a pipe that's undefined. It automatically numbers it. I'm going to do the same thing. I'm going to left click here, and I'm going to left click here, and I'm going to left click here just to show just general routing. I'm going to left click here, then come up, and I'm going to right click there to end it. Alright, so I'll hit the escape button. That gets me out of my little pipe routing tool, and I'll define these pipes. So the first one I want to define here is this first one I did. It's called pipe 3, and you come up here, and I already named, like I said, the fluid properties is seawater, and ours was water at 70 degrees Fahrenheit and 0 gauge, PSI gauge, so an atmospheric condition. So seawater, and a specification here up in this property grid as well. I already defined the carbon steel pipe, and I named it CS. So you select that CS, and remember that was up here in the system. We had defined those things. All right. and the size. You can size it based on a velocity in my setup, and our speed, our flow was 516 gallons a minute. So 516 gallons a minute says I need a 5-inch pipe. We're going to come back to that in a minute. I'm going to hit OK for now. We went ahead and set that as a 5-inch, but we'll revisit that in a minute, and I'll tell you why. All right, the length on the suction pipe was 50 feet. All right, and the fittings. The first thing we didn't want the elbows in here, so standard elbow. We said 10. You add that. We also wanted 2 butterfly valves, so you click on valves here, hit butterfly, put a count at 2, add that, it puts it in this little window here, and then alright, hit OK. So on our pipe here we have those things, and that's a K value for all those fittings that we put in it. So if you click on this first node, we want a 0 elevation, that's ABL, where our C chest is, hit enter. And on the second node, we're saying our pump elevation was at 5 feet, ABL, so we're going to say 5 feet, enter. And at the fire monitor, we said before, was at 105 feet, 105 feet. And then the fire monitor discharge pipe, we're going to select seawater, carbon steel, size we said was 5-inch, length 1,000 feet according to our strategy, our initial setup. And we want to go to fittings, standard elbows, and we wanted 40 of them here, big long stretch of pipe. And 2 butterfly valves, 2 butterflies, 1 globe. Now the globe valve simulates the fire monitor valve, so stick a globe valve in there, and then we have a check valve at the we'll call it a vertical swing check at the pump discharge. Hit OK. And now you have all of that information in that one pipeline. That's called pipeline 4 here, and you can drag those labels around. All right. So for our C chest here, you go and pick a tank over here on basic devices on the far left. Tank, left click, and then left click again. We got a tank. Hit escape to get rid of that. All right. The tank, we're going to call it C chest. And since I already have one on here named C chest, I'll call this C chest 2. Alright, so you put the name on it. Surface pressure is atmospheric pressure, 0 psig. Liquid level is going to be the water line, design water line, which is 10 feet. 10 feet ABL above baseline. So the water line is 10 feet above all this. So that's 5 feet above our pump. Our pump's at 5 feet. All right, so you got the water line in here. Our monitor, we said we wanted at 100 psi here. So how you do that, you pick a pressure boundary, you stick it on there, left clicks, hit escape to get rid of that selection. And pressure, we want 100 psig. All right. Now we have to size a pump. So what you need to do is hit a sizing pump. The type of pump doesn't matter yet. Stick a sizing pump on there, and hit escape to get rid of the selection that's dragging around, and hit operation over here on the property grid, and a window pops up. Tell it what flow you want, 516 gallons a minute. Hit OK and enter. All right. And once you've got all that in there, all your system design is in here. Up on the top screen in the middle is a calculate button. you hit that calculate button, and it tells you at your 516 gallons a minute, it tells you the TDH across that pump, total displaced head, or it says TH here, total head, 425.9 feet. All right, and you got 9 feet per second in this 5-inch pipe, and 9 feet per second in this 5-inch pipe. Now, I don't like 9 feet per second in a suction pipe, and ours is going to be a centrifugal pump, so we could very likely have suction head problems. So what I wanted to do here was just bump that pipe size up by 1, make it a 6-inch pipe. All right, and that gets us down to 6 feet per second, which I like much better. All right, so we've got a sizing pump, and that's not a real pump yet. So if you click on that pump, and then you right click on it and select catalog pump, I have pumps downloaded in here. These are free from the PipeFlow catalog downloads, and I'm going to look at an Aurora 60 Hertz pump. The 410 series gave us a couple of selections. The first one here, let's see, puts us at I'm looking for the pump power. Okay, 200 horsepower on the first one, 150 horsepower pump, motor on the second one. So we'd really like to stick with the 150 if that'll work, just to get costs. It looks like the first pump curve is has a little more shape to it than the second one. On a fire pump, it's nice to have a flat curve if you can, because the further you go out on pressure drop changes, or the further you go out on flow changes, you don't have that much of a pressure drop change. So we're going to select this second pump, and bam, it sticks it in there. And you can actually take a look at that pump curve by right-clicking on the pump and then selecting the graph, and you can see where we are on that pump curve. We're way up high, and we're just around 60% efficiency. We're not nearly over here where we would have a good operating efficiency, but that one will work for this situation. And you can actually go through there and look for other pump selections that might even be a better match, but we're going to stick with that one for now. And hit OK. You got your pump in there. You got your flow. Ended up at 523 gallons per minute based on all your system pressure drops with your fittings and valves and your monitor. And with all of that in there, in this pump, you've got a 100 psi at the monitor itself. So if you have 100 psi at the monitor, then you have our target flow, our target reach. So that's exactly what we wanted to do. And there you have your pipe flow example. That concludes part 2 of our video guide for the fire monitor design. If you missed part 1, please go click on that video and watch it as well for setup. And don't forget to go look in the video notes for there's a spreadsheet download in there, as well as links to the software used for this design. So thank you very much for watching. This video is a service of the engineeringjobLink.com.